Hi everybody, Mrs. Pesek here. We are looking at the 1516 quiz practice. And for number one, hopefully you noticed that the function is graphed and you had to find f of 3. So to find f of 3, we're looking 1, 2, 3 units over on the x-axis and we're up to a height of 1. So that means f of 3 is equal to 1. To find f of 5, we need to go 5 units over and we're up to 1, 2, 3, 4, looks like 5. Oh, I guess I didn't want to find f of 5. I wanted to find f of 1. So f of 1 is right here, but we're still up 5 units. So f of 1 is 5 and f of 5 also happens to be 5. But this was your answer for part B. Let's take a look at the next one. You're graphing the function on your calculator. So let's look at how to do that. Square root of 2x minus 5. My calculator is here. And I want to do square root of 2x minus 5 on my calculator. There's my graph. I'm trying to find the 0 of the function, which I'm kind of pointing to right there. I go Menu, Analyze Graph, 0, and I go to the left of it, lower bound, and click, and then I go to the right, and I click, and it shows me that the 0 is 2.5. If you're asked to find the 0 of the function algebraically, if you want to find a 0 of a function, that means you want to know when is my function equal to 0. So you set f of x equal to 0. So I have 0 equals square root of 2x minus 5. And then I would square both sides. And if I square both sides, 0 squared is 0. And the right side, square root and the squaring are canceling each other out. So I get 0 equals 2x minus 5. And I solve that, and I end up getting 2.5, which is exactly what we found on the calculator. All right, for number 3, it says find the average rate of change of the function from x1 to x2. So the formula for average rate of change is f of x2 minus f of x1 over x2 minus x1. So we need to find f of 4 minus f of 1 and divide by 4 minus 1. Well, off to the side here, I found f of 4. I got f of 4 to be 3 times 4 squared plus 2, which turns out to be 50. And I found f of 1 to be 3 times 1 squared plus 2, which turns out to be 5. So I plug those values in. So I plug in 50 right here, and I plug in 5 right here, and I get 50 minus 5 over 4 minus 1, or 50 minus 5 over 3, and that turns out to equal 15. So the average rate of change from x1 equaling 1 to x2 equaling 4 would be 15 units. Let's take a look at the next one. You're writing a linear function f such that it has the indicated function values. If f of 3 is equal to -1, that corresponds to the ordered pair 3, -1. 3 is the input, -1 is the output, and written as an ordered pair, we get 3, -1. Do the same thing with f of 5 equaling 7, and you get the ordered pair 5, 7. So the rest is all algebra 1. You're finding the slope of the line by doing difference in the y's over difference in the x's, and I got 4 to be the slope, and then I go to write y equals mx plus b, and I plug in 4 for slope, 5 for x, 7 for y, and I end up getting -13 as the y-intercept. I do want to write it as a function, so my answer would be f of x equaling 4x minus 13. And how about number 5? It says evaluate the function for the indicated values. Remember that this symbol means the greatest integer less than or equal to whatever's in there, right? So in the first example, your function is greatest integer less than or equal to x minus 6, and you're trying to find f of 2.4. So you're going to plug in 2.4 for x. 2.4 minus 6 is -3.6. And what is the greatest integer that's less than or equal to -3.6? Well, picture it on a number line. Here's -3, here's -4, here's that -3.6. We want the greatest integer that's less than or equal to, so it's going to have to be -4 as our answer. And for part B, we're trying to, we have the function g of x equaling -3 times the greatest integer less than or equal to 2x. And we want to find g of -0.3. So I got -3 times the greatest integer less than or equal to 2 times the -0.3. And so that's 2 times -0.3 is -0.06. Again, picturing it on a number line. Here's 0, here's -1, here's -0.6. I want the greatest integer that's less than or equal to that, so I have to go with -1. So I get -3 times a -1, which is a +3. All right, and the last problem, which I guess I should have called number 6, but I just jumped right to number 7. So sketch the graph of the function. We're graphing y equals 2x minus 3, so the y-intercept is -3, and the slope is 2. So up 2 to the right one, up 2 to the right one, down 2 to the left one, down 2 to the left one. So I could draw in my whole line, but I don't want to keep the whole line. I only want to keep it for x strictly less than -1. So I'm going to erase everything like this, and I'm just going to keep this piece of the graph right here. And remember, that has to be a hole in the graph at -1, 2, 3, 4, 5. At -1, -5, that's a hole in the graph because we're not including that -1. And then we're graphing the other piece, which is just y equals x squared. That one, hopefully you know, to plot accurate points goes through 0, 0, -1, 1, 1, 1, 2, 4, -2, 4. It goes through 3, 9, -3, 9, and so on. We want not all of this graph, though. We only want it for x strictly greater than or equal to -1. So I'm going to erase everything over here that's greater than -1. And I'm just going to keep that much of the graph. All right, we do actually want a point here, not a hole in the graph, because we're including the -1. All right, so that wraps up this, and hopefully you are going to be all awesome on this quiz. Thanks for watching, and have a great day.